Alright, we're doing 15.5 from the homework. This is a pretty simple question. It just wants us to basically label the different parts, the different types of information we can get from a wave graph, not a wave graph, a wave equation. We're going to find the amplitude, the wavelength, the frequency, the speed of propagation, and the direction of propagation. So, let's get right to it. The amplitude is always the first number over here in front of the rest of this garbage. And for example, in this one, it's 6.50 millimeters. The wavelength is what is given underneath your distance variable. So over here we have x as our distance variable. So underneath that we have 28 centimeters, so we get a wavelength of 28 centimeters. The frequency is what's given underneath your time variable. So we have a frequency of 0.036. Now the speed of propagation, to find that, all we need to do is so the speed of propagation is, so speed is basically velocity times time. We have our time over here, and so in this scenario we want to find the frequency, which we did up here. Actually, hold on, I made a slight mistake here. So this is the time. Frequency is 1 over the time, so frequency would be 1 divided by 0.036, which equals 27.7 hertz. My mistake there. So anyway, the speed of propagation is just simply the distance multiplied by the frequency. And so 28 centimeters is the same thing as 0.28 meters multiplied by our frequency, 27.7, gives us a speed of roughly 7.7 meters per second. And last but not least, direction of propagation, we want to look at the sign in front of our time section. We want to look at this specific sign. Basically, whatever this, if it's positive or negative, we want to do the opposite of that. In this case, it's negative, so direction of proposition is in the positive direction. If this was a positive sign, then the direction of propagation would be in the negative direction. Basically the opposite of that. Alright, that should cover everything.